Welcome. This morning at 7:40 a.m. We're looking at simultaneous equations now. So we had a look yesterday at linear inequalities, and yeah, hopefully that went okay. This kind of has very little to do with that. Simultaneous equations are essentially trying to solve, you've got two variables, x and y, and you're trying to find what their values are. And that's fine because you're given two equations. You can only ever you have to have the same number of equations as variables to be able to solve something. So if we have two variables in here, well, I can't get an exact one number that would suit for both of these. For instance, like there's a multitude of x's that would give a multitude of answers for y. But if I wanted one very specific answer that was the only case, then I have to have two equations, and then I can put them together and solve that. Anyway, for starting off, what we're going to do is what's called solving graphically. And if we sketch both of these lines individually, this y equals x plus 2 and y equals 6 minus x, where they intersect, so somewhere on this graph, the intersection point and the x value of that is going to be an x value that would hold true for both of those things, and it would equal the same y. So let's just see how that goes. So sketch a pair of linear equations, y equals x plus 2 and y equals x minus 6. Now, if I'm trying to sketch this thing, what's the easiest way to do? Well, we had a look earlier. Probably the easiest thing to do there would be to find the x-intercept and the y-intercept. Firstly, the y-intercept is obviously just the constant on the end, because the y-intercept happens whenever x equals 0, and if I have y equals 0 plus 2, well, that clearly equals 2. So for my first equation, my y-intercept is going to be there. My x-intercept, slightly different. Remember, the x-intercept always occurs when y equals 0. So if 0 equals x plus 2, then what does x equal? I have to move the 2 over, and it would become negative 2 equals x. So the x-intercept is going to be down there. Now, fortunately, it's a linear equation, so that means that as soon as I have 2 points, I can line those up and draw the line between them. So I'm going to do that now. Hopefully about there. Painful. Okay. Yeah, that'll do. Okay, good. So we've got our line there, and that obviously goes on forever there and goes on forever down there, wherever it goes, no big deal. And this is the equation y equals x plus 2. No harm in labeling it. I'll change color and plot a different, the other graph now. So the other one is y equals 6 minus x. Now, I mean, clearly we can see the gradient here is going to be negative, so it's going to be a downward facing graph point thing. Not that that's necessarily important. I can still find it by finding the x-intercepts and the y-intercept. So the y-intercept clearly is when x equals 0, and y equals 6 minus 0, well then y just equals 6. No big deal. So I'm going to go y equals 6 and put my first point. That's my y-intercept. My line is going to pass through that point. And then for my x-intercept, well, that implies that the x-intercept is when y equals 0, so 0 equals 6 minus x, and I just took that from my equation here and just made y equals 0 because that is the substitution. Y equals 0 at the x-intercept, because the x-intercept occurs down here on that actual x-axis, and y is 0 everywhere along the x-axis. Okay, so moving my x across then, x equals 6. Great. So that means my second point is down here. Thing to note, don't get confused between what we were doing yesterday with the linear inequalities. I've moved, actually that has nothing to do with that. Forget what I just said, but I mean clearly don't get confused between those things, but it's not that you should in the first place. So don't worry about something that you shouldn't have worried about in the first place, and you probably weren't worrying about, but now you might be. So now I've got these 2 points, 6 and 6. Interesting, okay. Hopefully this is right, I think it is. And I've drawn my thing and line up between those two. That's great. Someone's just sent me a text message. It's Miss Rogers! Okay, all good. Now, what have I got here? I've got a point here. Now, this point it should be, and it's pretty close, I'm pretty close, but it's meant to be the point here, 2, 4. I'm just going to do it with a different color. Let's go with that one. So this point here, 2, 4, that's telling me that those are the values when x equals 2 and y equals 4, that would hold true for both of those equations. Now, when they say hence find a solution, we only really need to define one of them, and that's the x value, because obviously the y value will be the same. Now let's try that. If I substitute 2 into both of these equations, so the first equation, we'll call this equation 1, and we'll call this one equation 2. So equation 1 with, don't have to write with, but anyway, x equals 2. Let's see what that looks like. Y equals x plus 2, which is 2 plus 2, so y equals 4. And equation 2 with x equals... Now, I'll just clarify, you don't have to go into all this detail. I'm just showing us that, like, all of this we don't really have to do. Well, maybe... No, we don't. It's okay. I'm just showing you that they are the same thing. X equals 2, so then my equation 2 is y equals 6 minus 2, y equals 4. Oh, look at that. They came out to be the same thing, which makes sense. They should be, because as this is proved, at x equals 2, both of the graphs equal 4. And that's the main point there. So part A is essentially this thing here, which we can just call this part A. Part B would be hence find the solution. Well, clearly we've essentially found the solution. X equals 4 is the solution. And you could say x equals 4, y equals 2, but you don't have to. X equals 4 is... Wait, sorry, it's the other way around. Got that wrong. X equals 2 and y equals 4. This is the important part of that. Okay. We'll quickly move on to the next one. I think the next thing we're doing, we're just solving algebraically now. When we're solving algebraically, well, let's just get into it. Solve the following simultaneous equations algebraically using the substitution method. So the substitution method is a case of seeing so we're not making them equal. I guess that one's the sum using elimination method. Oh no, substitution. Okay. Is it that? Sorry, I'm just catching up on things. All right. I assume that they mean... Well, let's try substituting it in. Surely we could just make them equal. Yeah, whatever. Okay, substituting it in. Let's call this equation 1. Let's call this equation 2. Now, what do I know about equation 1? Well, I know in equation 1 that y equals 2x. And I know in equation 2, x plus y equals 18. Now, I've got two variables in this equation, and... that's not great, but I have two variables in this equation too. Okay. Basically, what I'm going to do is, I know what y is equal to. I know y is equal to 2x. So I'm going to replace this y with 2x. So I'm going to sub equation 1 into equation 2. What that's going to look like is I'm going to have x plus, and then instead of writing y, I'm not going to write y, I'm going to write what y is equal to. And apparently y is equal to 2x. So x plus 2x equals 18. Now, fortunately, I have one variable now. I mean, there's two separate terms, but it's one variable because I can collect these like terms because they're both in terms of x. So I now have 3x being equal to 18. And then clearly x is equal to 18 divided by 3, which is 6. I can test if that works, and you don't have to test it, but let's just do it for this demonstration's sake. X apparently equals 6. Now I want to test each of these to see if y equals the same thing. For the first one, y equals 2 times 6 clearly equals 12. For the second one, I'm going to have 6 plus y equaling 18. Well, I'll need to move the 6 over the other side, so I have y equals 18 minus 6 equals 12. So they both equal 12, done deal. Okay, I'm going to put the testing part in a different color because we don't have to do that. But the testing part is just, it's helpful to make sure you got the right thing. Second one, a little bit easier. Now, let's call this one equation 1 and this one equation 2. The difference being I know what x is equal to in terms of here. So in the first equation, I'm going to replace any time I see an x with what it equals, which is 3 plus y, or y plus 3. So I've got 2, and now I have to input this whole thing. I'm going to have to put it in brackets because it's a term here with an expression almost, with y plus 3. So y plus 3. So instead of writing 2x, I've just written 2 and then y plus 3. I've substituted in what x is equal to for x. Okay, plus 3y equals negative 4. And now I just have one equation with one variable. There's only one unknown in there. So let's expand this part here. So 2y plus 6. Don't do 2y plus 3. It's 2y plus 6 because we've got to multiply 2 with y, and then we've got to multiply 2 with 3. Plus 3y equals negative 4. I'm going to do a couple things here. I'm going to move the 6 over, and I'm going to combine 3y and 2y. I'm going to collect those like terms. Well, 3y plus 2y is going to be 5y. And then moving a 6 over would make it negative, so negative 4 minus 6 would be negative 10. Now the only thing I need to get rid of is the 5 over here to get y on its own. So let's get y equals negative 10 over 5. I'm running late, let's get this done. That clearly simplifies to be negative 2. And I'm almost done, but when we're talking about solving, then I need to get the value for x. And that's fine, because I'm going to call this part equation 3, and if I know the value of y, then I can find out the value of x. And let's substitute that into equation 2. So 3 into 2. Why do I do all this labeling? Because it's so much easier to follow, especially when someone's marking. And if your marker can follow what you're doing, then they are going to be happy with you and likely be kind, unless it's all completely wrong, then it doesn't make a difference. Okay, 3 into 2, so equation 2, x equals, now instead of writing y, I'm going to write negative 2, because that's what y equals, negative 2 plus 3, and so x clearly equals 1, and that's my solution. I'm not going to go through and prove it. We've got another one to do. You can pause that if you need to. Moving on to this one, solve the simultaneous equations by using the elimination method. Okay, elimination method is basically adding or subtracting both equations to each other. So if I have equation 1 here and equation 2 here, and I go equation 1 plus 2, well then I'm going to add the left sides to each other, and I'm going to add the right sides to each other. So the left sides adding together would be equation, so 1 plus 2, then it's going to be 3x plus 5y plus x. Now I'm now adding this part minus 5y. Okay, I've taken care of the left side, and that's equal to negative 3 plus 19. This one plus this one. Now, why did we do that? Well, clearly I can see I've got a positive 5y and a negative 5y here. And that's helpful because if I add them together, they're going to disappear, and then I'm left with just one unknown, which is the x on each of these things. So 5y minus 5y equals 0, so I'm left with 3x plus x, and what's that going to equal? 4x. Well done. Excellent, people. Negative 3 plus 19 is clearly going to be 16, and I've got 4x equals 16, then x dividing both sides by 4, and x equals 4. I could then test that by substituting that in, and I'll let you guys do that. And you can see that if you sub in x equals 4 into equation 2, you'll get a solution, and if you you'll get an answer. And if you sub it into question 1, you should get the same answer, unless I've done something drastically wrong. For this one, I'm going to do the same. I'm actually going to do almost the same thing. I'm going to take them away. Again, I've got terms here that are the same, but their sign is the same as well. So if I add them together, I just get 8x, and that's not helpful. If I subtract one from the other, then I can get 0x, and that's going to be helpful. So let's go equation 1 minus 2. So I'm going to have 4x plus 5y minus 4x, and this is the key part here. In fact, it might be beneficial to go minus and then open a bracket and say 4x minus 3y and put exactly the same thing that you've put in there, purely because we've got a negative 3y and a negative here, and they're going to result in being a positive when I expand them out. So if I didn't put brackets, I would have had to write minus 4y plus 3y. You've just got to keep that in mind, that we're minusing everything in here. So the sign changes for everything. The 4y was positive, but now it's negative. And the 3y was negative, and now it's positive. But we'll get into that in a sec. And then I've got negative 6 minus 10, because I'm subtracting anything from equation 2 away. Alright, so let's just expand this first and get rid of this negative and basically do out what I'd done just before. 4x plus 5y minus 4x, because I'm timesing negative 1 essentially with everything on the inside, plus 3y. And the reason I'm doing that is because I subtracted equation 1 from equation 2, equals negative 16. Right, now I can collect like terms. 4y minus 4y is clearly going to be 0, so nothing there. Great, they're gone. Boom, boom. And then 5y plus 3y is 8y. So 8y equals negative 16. Clearly then y equals negative 16 divided by 8, which is negative 2. If I sub that value back into both of those equations, well, in fact, I need to sub it into one of them, because I need a value for x, don't I? Always need a value for x. Okay, let's call that equation 3, and then sub 3 into, it doesn't matter which one I sub it into, 1 or 2. I think that subbing it into, I have no idea, but I'm just going to go for 1. Why not? Y equals negative 2. So 4x now, plus 5 times negative 2 equals negative 6. So 4x equals, oops, not 4x equals, sorry, 4x minus 10 equals negative 6. And that then means that 4x equals, moving the negative 10 over becomes positive 10, negative 6 plus 10. So we're just going to go over here now. 4x then equals negative 6 plus 10 is 4. Clearly then x must equal 4. And there's my solution. Oh my goodness, there's still another one to go, and that's 758. Solve, elimination method as well. Okay, same deal. Probably just more complicated, because why wouldn't it be? 3x plus 2y, yeah, okay. So right now, the problem I have is none of these values are the same. I've got 3x's and 4x's here, and I've got 2y's and 3y's here. What I kind of want is I want the number of x's to be the same. So I'm actually going to have to I'm going to have to multiply this entire equation if I want to get, I'm going to decide to get the x's to be the same. I'm going to have to multiply this entire equation by 4. I'm going to have to multiply this entire equation by 3. I'm going to call that equation 1 and equation 2. So 1 times 4 implies every term in here is going to multiply by 4. So I'm going to get 12x plus 8y equals 20. This is my new equation. I'm going to call that equation 3. And equation 2 times 3 is going to imply everything in this equation is multiplying by 3. So 4x times 3 is going to be 12x. Great, now these are the same. That's what I wanted, but I still got to do everything else. Negative 3y times 3 is going to give me negative 9y, equaling negative 16 times 3. It's a bit tricky, but 48. And then it would be, what's 15 times 3? 45. So 4. Oh, it is 48. Is it? Yeah, 48. How did I know that? I don't know. Anyway, 16 times 3. So negative 48. I'm going to call that equation 4. I've jumped over here a little bit. Can we compress that? Let's see if we can just squish that in there. Look at that. Perfecto. Okay. Now I've got these two equations, and now they are fortunately both in terms of, I'm going to make them a different color because it'll look a bit easier on the eyes. They both have 12x's, so I'll subtract one from the other, and that'll make it a bit easier. So let's go equation 3 minus 4. So I'll take 4 away from 3. So then I've got 12x, let's go blue for some reason. Let's go 12x plus 8y minus 12x plus 9y. Why is it plus 9y? Because I've subtracted a negative, and it becomes a positive anytime. Equals 20 minus negative 48, which becomes plus 48, but I'll just leave it like that for now. 12 minus 12, 0, 8 plus 9 is 17y, so 17y equals, and 20 plus 48, because minusing a negative is the same as adding a positive, is going to be 68. And so then y equals, and now I genuinely don't know what that is, but let's divide 68 by 17, and hope that it comes out with a nice number, and it does. So 68 over 17, and y equals 4. Am I done? Almost. Sorry. I still have to find x. So in hindsight, I probably should have done the whole thing about getting rid of y first. Ugh, whatever. Anyway, y equals 4. Subbing equation 5 into 1. Let's do that. 3x plus 2 times 4, because instead of writing y, I'm writing 4, equals 5. 3x plus 8 equals 5. So 3x equals 5 minus 8, which is negative 3. X must be equal to negative 1, because dividing both sides by 3, obviously, it would be negative 3 over 3. Negative 3 over 3 is negative 1. Solved. If I chuck that back into any of these, it'll all come out true. Last one. This one's easy because I don't have to multiply the first equation by anything. I can just go, this is equation 1, this is equation 2, and if I multiply equation 2 by 2, then I would get a 2x, and a 6y, and a negative 10, and still a 0, because 0 times 2 is still 0. And then I can subtract 2 from 1, so let's just do that. So I've got equation 1, that's fine. I'm going to go equation 2 times 2, which would give me 2x plus 6y minus 10 equaling 0. And let's call that equation 3. And then 3, let's go 1, equation 1 minus 3, and see what happens. I'm going to have 2x plus 5y minus x minus 3y. Sorry, not minus x. I just went back to equation 2. I need to go to equation 3. So minus 2x minus 6y plus 10. Again, I'm subtracting a negative, so it becomes positive. So yeah, this becomes negative, this becomes negative, this becomes positive. Equals. It's still going to be 9 minus 0, so it's still 9. Good. Now I've got 2x minus 2x, that goes to nothing. I'm going to have 5y minus 6y. What's 5y minus 6y going to be? Negative y, or negative 1y, plus 10 equals 9. Great, so negative y equals, subtracting 10 from both sides, 9 minus 10, and that's negative 1. Now if negative y equals negative 1, times both sides by negative 1, disappears, y equals 1. Sub that, equation 4, let's substitute that back into what I think will be the easiest, which would have to be equation 2. 3. 2, 3. We haven't used 2, so we'll just leave 2 alone. We'll go with 1. Subbing that back in, so 2x plus 5 times 1 equals 9. Well, 5 times 1 is just 5, so 2x plus 5, I'll move this whole thing to the other side, it'll be minus 5, equals 9 minus 5, which is equal to 4, I believe, I think, yeah, hopefully. So then 2x over 2 equals 4 over 2, x equals 2. Solved. Thank you very much. See you soon, or whenever. Maybe never. Who knows? That's all for today. So do questions based on those, and I will leave that in sector for everyone. Bye.